Hi again. Okay, I had a restless night, thinking about uh, dark matter. Um, Actually, the thing that was brought up to me was perhaps it's a misnomer to call it dark matter, and perhaps we should call it clear matter. Okay, because in fact it's clear and you can see through it. Um, we can see through air, and it has an index of refraction, which is indicated, and we can see through water, which also has an index of refraction. So for dark matter to have an index of refraction is only proof that it is actually matter, okay, not antimatter or something else. So here we have dark matter and clear matter, doesn't matter, um, and this clear matter, okay, we sort of only know three states of matter. Well, there's actually four states, plasma, but most of the states that we're familiar with are solid, liquid, and a gas. And basically, we don't know what the state of clear matter is, whether it's a solid, liquid, or a gas. Now, I would propose that we first of all determine whether it's compressible. Okay. Now, dark matter doesn't interact with anything, but it does have a mass. So if it has a mass and it's in a gravity pool of Earth, then it should be denser if it's compressible, closer to the surface of Earth than it would, say, be in space. Okay, assuming that dark matter is everywhere. Okay, if we were to do in the shuttle, measure the speed of light using the same apparatus that we did on Earth, and get the same speed as we do on Earth, then we would have to conclude that clear matter is either a liquid or a solid. Now, it can be a solid because if we can't interact with it, it could easily be a solid. So, how to determine whether it's going to be a solid or a liquid, um, I haven't got that far yet. But anyway, so this would be my proposal to sort of extend our knowledge of clear matter would be to measure the speed of light on the space station, based on the idea that there should be a lower density if it's compressible gas or compressible matter, and meaning that its state was as a gas. My guess is that you probably will find that it's not a gas, and that it's incompressible. Now, this brings up some other questions, though. We arrived at our index of refraction for dark matter because an assumption was made when they did the experiments to determine the speed of light on Earth. And one of those assumptions was that basically there was no dark matter. But this then, if there is dark matter, that means that assumption was incorrect. And one of the earlier assumptions was that there was no sort of ether, which light could travel in. So perhaps all of this should be looked at again. So perhaps light, a photon, when it travels through space between galaxies where there is no dark matter, perhaps it travels as a particle, and it just moves at the speed of light as a particle. Yet when it encounters dark matter, all of a sudden it takes on because it's now traveling through a medium, it now takes on its characteristic wave function. So perhaps this would provide us with an idea of the duality of light, the particle wave theory of light. Perhaps light will not travel as a particle wave in the absence of clear matter. Anyway, this is all a thought. I'd appreciate hearing back from anybody who actually looks at this stuff and doesn't think I'm totally out of my mind. Anyway, thank you very much, and thanks for your time.